Hello, this is Mr. Stansbury. I'm going to take you through the 11I assignment. All right, so we start on number 3 here. And when work has to be done on underground telephone cables, workers often use a small tent over the opening. It helps them from bad weather and from people falling in the hole. The cover is constructed from canvas and supported by a tubular steel frame, as shown below. Use the measurements from the diagram of the frame to calculate the following. Part A is the length of steel tubing needed to make the frame. So that's just going to be all these lines that we see. That's all those lines are going to be the steel tubing, with the exception of this 140 line here. Okay, so it looks like we have everything we need except for these diagonal pieces right here. So what we can do, we just need to be able to calculate what that is. So let's do this. Let's make this here into a right triangle, right? So we cut this side exactly in half. So that's 120. This is now 60. And if it from here to here is 100 and here all the way to the top is 140, if we subtract those two, 140 minus 100 gives us that this has to be 40 centimeters as well. Okay, so now to figure out what this here is, we can just do 40 squared plus 60 squared equals c squared, right? A squared plus b squared equals c squared. So, excuse me, let's figure that one out there. So, we got 40 squared plus 60 squared gives us 5,200. Is c squared, so we want to find out what plain old c is, so let's square root both of those sides there. So we square root our answer and we get 72.1. So we'll call this 70. Oops, that's not pretty. Let's get rid of that. Okay, so that length right there now is 72.1 centimeters. Okay, so now we should be able to calculate the total length of steel tubing needed. Okay, so let's see. Let's do these. So we got all of these here. 1, 2, 3, 4 back there, 5 here. So we have 5 that are 150 centimeters long, and then we have 1, 2, 3, 4 in the back here that are 100 centimeters long, right? And then let's see, that just leaves us with these 4 pieces here, which we just figured out are all 72. So that's 72.1, 72.1, 72.1, 72.1. So there's 4 that are 72.1, and then we have 1. There's no steel beam there. Tubing, sorry, and then there's another one back here. So that's 2 that are 120 centimeters long, right? So we'll just add those all up. Okay, let's see. 5 times 150 is 750, right? 4 times 100 is 400. 4 times 72.1, not sure on that one, but this one is 240. So let's do 72.1 times 4 gives us, oh, I got 721. Let's try that again. 72.1 times 4, that's better, 288.4. Okay, let's maybe just call that 288, shall we? So now we can add all that up. Right, so I'm going to do 750 plus 400 plus 288 and plus 240. Right, and that gives us 1678. 1,678 centimeters, or you could turn it into 16.78 meters. Either one of those should be just fine. Okay, let's figure out B then. The amount of room inside the tent. The volume in cubic meters. So volume inside the tent here. So, excuse me, for volume, we're just going to want to we're going to want to figure out the area of this base here and multiply it by its height, right? So the area of this front face. So we can look at it here. We've got this rectangle here and this triangle right here, and we have all the dimensions for all those, so that should work out. So let's do the base. We'll do base times height. Alright, so we got our base times our height. So the base, we want to figure out the area of this base right here and multiply it by the height, which would be this. Okay, so the base is going to be this rectangle here, which is 120 by 100. And then we also have to add on the area of this triangle. So again, the base of this triangle is 120. And then the height of that triangle is 40. And we got to take all of that, and we got to really take all of that and divide it by, it's really 1/2 of all that, right? So let's move that out of the way. And we got plus 1/2 times 140 times 120, right? Times 120 times 40. Okay. So let's put that in our calculator here and see what we get. So we got 120 times 100 plus 0.5 times 120 times 40. That gives us 14,400. Okay. And then we got to end up taking all of this and multiplying by the height, which is 150. Right? So multiply that by 150 times 150, and we get 2,160,000. So 2,160,000 cubic centimeters. Let's do this. Let's turn that into, I'll move this up so we can see this a little better, a little bit more room to work. So let's, that's a lot. That's a big number here. So let's turn that back into cubic meters. Okay, so that's going to equal how many cubic meters? So again, if we've got our King Henry died unexpectedly drinking chocolate milk, to go from centimeters back to meters, that's moved over twice. But we're doing 3 dimensions of that, so we got to move it over twice 3 times. So that's a total of 6. So 1, 2, 3, 4, 5, 6. So it would be 2.16 cubic meters would be the volume inside the tent. Okay. C, the amount of canvas in square meters needed for the cover. So now we figured out the volume. Now we need to figure out the surface area. So let's do that here. So let's see, we've already figured out the surface area of the front and the back. That's what this is. This is the so we got front and back. Let's write down all the things we need. So that is going to be 14,400, and that's 2 of those. Okay. We also need the left and right. Right? So that's going to be 150 times 100. So that's 150 times 100, and there's 2 of those. Right? And then we also, let's see, the bottom won't need any because that's the open part of the tent. So we just need the 2 tops. So that's going to be 72.1. So that's we'll put the 2 tops, or the left and the right part of the top, whatever you want to call it. 72.1. So that's 72.1 by 150. And there are also 2 of those. Okay, so we should be able to multiply these out and add them all up to get our total surface area, right? Okay. So we got excuse me, 400 times 2 gives us 28,800. And then we have 150 times 100 times 2, which gives us 30,000. And then we got the 2 top parts, and that's 72.1 times 150 times 2, and that is 21,630. Okay, so we add those all up, and we get, let's see, add one there. It's 3, 4, 5, 6, 7, 8. 80,430, and this is all in centimeters, right? So this is centimeters squared. But they said they wanted it in meters squared. So again, if we're going from meters to centimeters, well, centimeters back to meters, again, that's 2. And since we're only 2 dimensions, we got to do that 4 times. We got to do that, move it over 2 spots twice. So we would go 1, 2, 3, 4. So that's going to equal 8.0. Let's go with 8.04 meters squared of fabric. Okay? And then part D, how many people do you think could comfortably work in this tent? If there was a sudden downpour of rain, what do you think would be the maximum number of workers who could shelter in the tent? Okay, so 100 centimeters tall. 100 centimeters, let's convert that into inches, right? So 100 divided by 2.54, it's about 39 inches, so that's a little more than 3 feet tall, and that's going to be about 4.5 feet long. So, I mean, I don't know, I'd go with, comfortably, none. That's not going to be comfortable to be hunched over in that thing, but probably 2, maybe 3 people, but of course there's a hole in there somewhere, so I'd go with probably, again, still none, but maybe 2 or 3. Okay? Alright, let's move on to the second and last. Okay, so here's number 4. A ready-mix concrete tanker is to be constructed in steel in the form of a cylinder with conical ends shown alongside. Show your working in the following questions. Part A, calculate the volume held in the tanker by working out the volume of the cylinder. So, conical ends. Calculate the volume held in the tanker by working out the volume of the cylinder. Oh, and the conical ends. Okay. So, we're basically telling us find the volume of this cylinder here, and then add the 2 cones in as well. Okay, so that means we're going to need to figure out our volume formulas, right? Let's track those down. Okay, so track those 2 down, and that's these over here. Okay, so let's do the easy one. Let's figure out the volume of the cylinder here. So it's the area of the end multiplied by the length. So if this whole thing here is 1.8, that means that the radius of this thing is going to be 0.9 meters, right? So for part A, the area of the circle on the bottom there is going to be, of the base we'll call it, is going to be pi r squared, right? So the volume equals pi r squared, and then we got to multiply it by the height, right? So volume is going to be pi times 0.9, well really that's 0.9 meters, right? Meters squared. Oh, we're going to square it here later. There we go. Meters squared times the height, which is, of this thing here, it's just 4 meters long, okay, times 4 meters. So let's see what we get for that. So we got pi times 0.9 squared times 4, and that gives us 10, let's call it 10.18, and that is going to be meters cubed of volume there. Okay, so now we need to come up with the volumes of each of these cones here. Right, so that's here, volume of a pyramid or cone, 1/3 the area of the base times the height. So we want to figure out what that is there. So if this whole thing here is 4 and this whole thing is 6, that means that each one of these have to be 1 meter, right? So from here to here is a meter, and here to here is a meter. These 2 cones are identical, so we really just need to find out the area of one of those, the volume of one of those, and then double it, right? So we got volume equals 1/3, and that's the area of the base, 1/3 pi r squared times the height. So in this case we have 1/3 pi times our radius here is 0.9, squared times the height, which is just 1. Okay, and those are meters. And we've got 1 divided by 3 times pi times 0.9 squared times 1. Right, and that gives us 0.848. But remember, there's 2 of these, so really we should take this whole thing times 2 to get our total volume. So let's multiply that by 2, and we get 1.696, so let's call that 1.70. 1.70 meters cubed, right? So now if we add those two together, 1.7 plus 10.18, we end up getting 11.88 meters cubed. So our total volume is 11.88 meters cubed. Okay? Alright, so that's the total volume of that whole thing. How long would the tanker be if the ends were hemispheres instead of cones, but the cylindrical section remained the same? Explain your reasoning. This question here always seems to confuse people a lot. It's just it's a strange way to word it. But what they're basically saying is get rid of the cones, and now instead of cones, they're going to be these round spherical things here. They're basically just going to be like half of a ball. Okay, so they're saying what would it be then? Okay, so if we're going to do they're basically just asking how long is it going to be. They're not even asking us to calculate anything else besides that. So if this was a sphere and this radius here remains at 0.9, which it would be, that means that this height here, instead of being 1, would also be 0.9, right? So that means we'd have 4 plus 2 0.9 ends. So instead of being 6 meters, it's going to end up being 5.8 meters long for part B. Okay? Okay, moving on. We've got part C. How much more or less concrete would fit in the tanker if the ends were hemispheres instead of cones? So let's see, we know that the volume of the 2 cones were this. So let's just figure out what the volume of the 2 hemispheres would be. Okay, let's keep doing that in red. So this is really a little bit more part C. So the volume, it basically is going to be the volume of an entire sphere, right? So the volume of a sphere, let's look that one up. Volume of a sphere is 4/3 pi r cubed. So volume equals 4/3 pi, and our radius now we know is 0.9 meters cubed. So let's figure out what our volume is going to be here. So we got 4 divided by 3 times pi times 0.9 to the 3rd power. Right? So, alright, so our volume ends up 3.05 cubic meters, and the volume with the 2 cones on the end is 1.70. So if we take 3.05 and minus 1.70, we end up getting, let's see, what, because that's now 1.35 cubic meters more if we put the sphere on there. Okay, so better with the spheres on the ends. Let's see, let's move on to D. The surface area of the tanker with conical ends is about 30 meters squared. The tanker with the hemispherical ends has a surface area of near 33 meters squared. Verify one of these figures by your own calculations. Interesting. So they're basically saying, trying to figure out the surface area of either the one with the cones or the spheres on the end. Okay, so we can do that. Let's try that in a different color so we don't get too confused here. This is part D. Okay, so surface area of a cylinder here is just going to be the surface area. Let's see, I'm going to just paste it right over. I'm going to put it over here with our formulas right here. Okay, so here's this is the cylinder, and then this is the cone. Okay, so cylinder is 2 times pi times radius times height. So surface area of the cylinder is going to be 2 times pi. The radius is 0.9, and the height of this thing is 1. Okay, 0.9 times 1. Okay. Let's see. Let's just figure that one out. Okay, so we got 2 times pi times 0.9 times 1 gives us 5.65. Oh, wait a minute. I did part cone, part cylinder. Let's try that again. Because we did 2 times pi times the radius, and then the height, is 4, not 1. There, that's better. Because we're doing the cylinder, not the cone. We'll do the cone in here in a second. So let's try that again. Let's see, we got 2 times pi times 0.9 times 4. There we go, 22.6 we'll call it. So the area on that is 22.6 square meters. And then the area of the 2 cones are going to be pi times the radius times, we got to figure out what the slant height is. Tell you what, we can, you know what, let's just do it. We're here, we might as well do that. So this is just going to be, there's our right angle. This is going to be the slant height. So to figure that out, that's just going to be 1 squared plus 0.9 squared. So 1 squared plus 0.9 squared is going to equal the slant height squared. Alright, so we know that 1 squared is 1. So we take 1 and we're going to add it to 0.9 squared. That gives us 1.81, and then we square root that answer and we get 1.345. So let's call it 1.35. So that's 1.35 meters for our slant height. So times the slant height. So area is going to equal, let's see, I don't know why I'm copying down this formula here again. It's right over there. Let's get rid of that and let's put in our numbers. So we've got the area is pi, slant height is 1.35 we're going with. Oh, and then the radius, I got those two backwards, but it's not going to make any difference, 0.9. Okay, so 1.35 times pi times 0.9 gives us 3.817, so we'll call that 3.8. Okay, now that's just for one of the cones, so we got to double that to give us, so we got 3.8 times 2 of those and gives us 7.6 meters squared. So let's see what we get when we get 22.6 plus 7.6. Let's see, the 0.6's together is 1.2, add 1 to that, 23 plus 7, that's 30.2 meters squared, which is right about what we're supposed to get. Okay, so we ended up figuring that out. That's the conical end, so that's good. Okay, and then last part, part E, using the figures you have from A to D, discuss the advantages of each design. Overall, which is the better design for the tanker? Give your reasons. So, I don't know. I think it seems like it's pretty safe to bet that look, the hemisphere ones, it's a little bit shorter. It carries more. It carries more volume by 3 extra cubic meters. That's a lot. So, and I can't imagine it's going to take. Let's see, did we figure out? Oh, they tell us, no, sorry, it doesn't carry that much more, but it does have, let's see, the hemispheres. It's got more surface area for the hemispheres. So, I don't know, maybe it would be better to put the ones with the cones on the ends. It'd be an extra 0.2 of a meter long, but that's, I mean, that's pretty negligible. That's like only like about what, 4 or 5 inches or something like that, right? So I guess the cone ones maybe, because it's less surface area, doesn't cost as much to make the tank, right? Make the tanker, right? And of course, also making a round end probably seems like that'd be a lot more difficult to construct. Anyway, overall, the better design, yeah, your call. Okay, that should be all. That's all there is for this one here. So if you have any other questions, please feel free to ask in class. Thanks.